and welcome to today's lesson. I'm Mrs. Miller. Today, we will explore the question, what do we observe during a solar eclipse? Are you ready? Grab your pencil and your science journal, and let's get started. In our last lesson, we observed that light energy from the sun is blocked during a solar eclipse, making it dark outside. Other than sight, what senses can we use to make observations? We can use our sense of hearing, touch, smell, or taste. Now imagine you are watching a solar eclipse in person. What do you think you might feel during a solar eclipse? Well, I know we feel heat when we see the sun during the day. And when the sun goes down at night, the air feels colder. Do you think you might feel the temperature decrease during a solar eclipse because the sun is blocked? Maybe. Today, we will investigate how temperature might be affected by a solar eclipse as we continue to explore the question, what do we observe during a solar eclipse? I have a thermometer, a stopwatch, and a circle of cardboard. How can we use the circle of cardboard and the thermometer to investigate how temperature is affected by a solar eclipse? The thermometer measures temperature. We could block the sunlight with the cardboard circle to represent a solar eclipse, and then use the thermometer to measure temperature. We could measure temperature before, during, and after the cardboard circle blocks the sun to model changes in temperature before, during, and after a solar eclipse. What will we time with the stopwatch during this investigation? Well, a stopwatch allows us to keep track of time. So we can use the stopwatch to time 1 minute between each temperature measurement. Let's read our investigation plan. We will place the thermometer flat on the ground in a sunny location. Then we will start the stopwatch. We will read the temperature on the thermometer after 1 minute, and then after each minute, up to 5 minutes. We will record the temperature data. Next, we will hold the cardboard circle above the thermometer to cast a shadow that completely covers the thermometer. We will start the stopwatch again. We will read the temperature on the thermometer after 1 minute, and then after each minute, up to 5 minutes. We will record the temperature data. Finally, we will remove the cardboard and start the stopwatch again. We will read the temperature on the thermometer after 1 minute, and then after each minute, up to 5 minutes. We will record the temperature data. Before we begin, let's make a prediction. What do you think will happen to the temperature when we block the sunlight with a cardboard circle? Keep your prediction in mind as we investigate. Here is the thermometer in direct sunlight before the solar eclipse. We will measure the temperature each time in degrees Fahrenheit. After 1 minute, the temperature was 104 degrees. After 2 and 3 minutes, the temperature stayed 104 degrees. After 4 minutes, the temperature still remained at 104 degrees. 1 minute later, the temperature stayed the same at 104 degrees. Now, here is the thermometer in the shade of the cardboard circle when the sunlight is blocked. After 1, 2, and 3 minutes, the temperature was 100 degrees. After 4 minutes, the temperature was 98.2 degrees. And after 5 minutes, the temperature was 96.3 degrees. Finally, I put the thermometer back in direct sunlight. After 1 minute, the temperature was 98.1 degrees. After 2 and 3 minutes, the temperature stayed the same at 98.1 degrees. After 4 minutes, the temperature was 102.2 degrees. And after 5 minutes, the temperature was 104 degrees. I put the data in this table. What patterns do you notice in the data? Do you notice that the temperature went down when we blocked the sunlight and back up when we removed the cardboard circle? I noticed the same thing. When sunlight is blocked, the temperature gets cooler. What do you think happens to temperature during a solar eclipse? Do you think the temperature decreases during a solar eclipse? I do too. What is our evidence? When we blocked sunlight with the cardboard circle, the temperature went down. The temperature goes down when direct sunlight is blocked, and direct sunlight is blocked during an eclipse. Scientists have observed the temperature decrease during solar eclipses. In our last lesson, we watched video clips from an eclipse that occurred in 2017. During this solar eclipse, the temperature decreased by about 4 to 8 degrees Fahrenheit. In our last lesson, We also determined that the sun is a source of light energy and that light energy is blocked during a solar eclipse. Thermal energy is another type of energy. We cannot see thermal energy. Adding thermal energy causes objects or materials to heat up. Removing thermal energy causes objects or materials to cool down. The more thermal energy an object or material has, the higher its temperature will be. Is the sun a source of thermal energy? I think so. What evidence do we have to support our answer? The thermometer temperature reading is higher in direct sunlight and lower in the shade, so the sun must provide thermal energy. Let's update our chart. Last time we wrote, the sun is a source of light energy. Now we can say, the sun is a source of light energy and thermal energy. Your task after this lesson will be to update this chart. People use light energy every day. The sun is one of many light sources. And guess what? People also use thermal energy every day, as some of that thermal energy comes from the sun. Look at these photographs. Do you see any photographs that show ways people use thermal energy? Circle them with your finger. Did you circle these photographs? Great! Thermal energy is heating this water, and the people in this photograph are using thermal energy to warm their hands. What is happening in this photograph? Thermal energy from the sun is drying the clothes. Each of these photographs shows a different source of thermal energy. Let's look at the model we made in our last lesson. What happens to the temperature on Earth during a solar eclipse? During a solar eclipse, the temperature decreases because thermal energy from the sun is blocked. What can we add to our model to show our new understanding of thermal energy and solar eclipses? I know. Let's add thermometers to show that the temperature decreases during the eclipse and increases after the eclipse. What can we add to the explanation? Let's say, during a solar eclipse, the temperature decreases because thermal energy from the sun is blocked. We have learned about light energy and thermal energy. Do you think there are other types of energy? I think so. In our next lesson, we will explore a different type of energy. Let's review your task for today. Update the chart with your new